The world of ultra-compact drones is about to undergo its biggest shift yet, and if you thought the previous generations reshaped how creators capture on-the-go footage, what is heading our way next is going to completely redefine personal aerial cinematography. Over the past few months, supply chain tracking, insider patent filings, and flight testing logs coming out of Asia have pointed toward a massive leap forward in microdrone engineering. We are looking at a device designed to breach the boundary between casual selfie drones and cinema-grade flying cameras. Rumored, discussed, and now increasingly confirmed by key industry leaks, the DJI Neo 3 is shaping up to be the most ambitious compact drone ever created. If you have been waiting to see how far miniaturized flight technology can go before hitting physical limits, you are about to find out that those limits have just been completely rewritten. For years, content creators, solo travelers, and outdoor enthusiasts have been forced to choose between portability and performance. You either carried a heavy, fully featured aircraft with complex controllers and setup procedures, or settled for a lightweight toy that struggled in high winds, delivered noisy low-light video, and offered basic flight times. The DJI Neo 3 aims to erase that compromise entirely. Internal testing documentation suggests this upcoming release focuses on three major pillars: advanced spatial intelligence, an upgraded high dynamic range optical sensor, and an unprecedented power-to-weight ratio that pushes small-form aircraft into professional territory. Welcome back to my channel Tech Rivet for exclusive insights into the future of tech. Subscribe my channel, hit the bell icon for more tech updates. What makes this upcoming release so crucial to understand right now is not just that it is smaller or faster, but that it changes the fundamental relationship between the camera operator and the flying lens. To appreciate why the tech community is paying such close attention to the DJI Neo 3, we have to look closely at the rapid evolution of lightweight flight hardware. When microdrones first entered the consumer space, the primary obstacle was physics. Batteries were too heavy, processor chips consumed far too much power, and optical sensors small enough to fit a sub-250-gram frame suffered from terrible dynamic range and aggressive grain in anything less than perfect sunlight. Early compact models felt more like novelties than serious filmmaking tools. But over successive design cycles, engineering teams have relentlessly optimized every millimeter of internal real estate. Circuit boards were compressed using multi-layer stacked architectures, carbon-infused plastics replaced heavier polycarbonate shells, and heat dissipation was re-engineered using microduct airflow channels. With the DJI Neo 3, that cumulative evolution culminates in a machine that feels less like an iterative upgrade and more like a total generational leap. Industry insiders who have monitored prototype testing report that the structural architecture has undergone a radical redesign. The frame utilizes a refined high-density composite matrix, balancing structural rigidity with weight distribution to keep the drone agile in turbulent conditions while keeping total takeoff weight comfortably beneath strict regulatory registration thresholds. The outer cage and integrated propeller guards, which proved so popular for indoor shooting and safe palm takeoffs in earlier models, have been redesigned with aerodynamic duct fan contours. This non-traditional frame design reduces drag during high-speed forward flight, allowing the battery to draw significantly less current while cruising against strong winds. When we examine the camera package rumored for the DJI Neo 3, the jump in creative capability becomes undeniable. Earlier ultralight drones were constrained by small half-an-inch or modest 1/1.7-inch image sensors that struggled the moment the sun dipped below the horizon. The new sensor configuration being integrated into this compact frame is built around an expanded, larger format imaging plane equipped with next-generation back-illuminated pixel technology. This design allows for vastly superior light collection per pixel, drastically reducing digital noise during blue-hour shoots, city nightscapes, and dense forest canopy runs. Creators will no longer be limited to bright midday conditions to capture clean, usable footage. Beyond hardware light gathering, the color science and dynamic range capabilities embedded in the DJI Neo 3 processing pipeline represent a major win for filmmakers. Leaks indicate full 10-bit color profile support alongside custom flat log modes, giving videographers room to grade shadows and highlights in post-production without tearing the footage apart. Combined with enhanced high frame rate options, including high-speed 4K recording for buttery-smooth slow-motion tracking shots, the visual output matches what was previously achievable only on mid-tier professional drones costing twice as much and weighing 3 times as more. Stabilization is another area where the DJI Neo 3 sets a new benchmark for ultra-portable aircraft. Traditional mechanical gimbals on tiny drones have always been vulnerable to wind vibration, hard landings, and sudden motor torque spikes. To solve this, the engineering team has implemented a hybrid stabilization ecosystem. A high-precision mechanical gimbal handling pitch and tilt axis movements is coupled with an advanced AI algorithmic stabilization layer. This digital stabilization engine processes real-time telemetry from high-frequency inertial measurement units, micro-correcting frame movement at thousands of calculations per second. Whether you are running down a rocky trail, biking through uneven terrain, or launching in coastal breezes, the captured horizon stays horizon-locked and jitter-free. Flight time has historically been the primary frustration point for many drone pilots. Flying for 10 or 12 minutes before having to land, swap batteries, and recalculate flight paths disrupts creative momentum and limits complex tracking sequences. Leaked battery testing logs for the DJI Neo 3 point toward an optimized lithium-ion chemistry layout with higher energy density per gram than any previous compact battery pack. Combined with the refined duct airflow frame and hyper-efficient brushless motors, expected real-world flight times are surging well past previous records. Pilots will finally have the breathing room required to execute multi-take cinematic orbits, long follow-me sequences, and exploratory pathfinding without constant low battery warnings interrupting the workflow. Power delivery and thermal control are critical elements of this new battery and motor synergy. Microdrones generate immense internal heat because the processor, imaging chip, and electronic speed controllers are squeezed into a tiny closed cavity. Thermal throttling can cause dropped frames, reduced transmitter power, or shortened flight times. In the DJI Neo 3, an active internal thermal ducting system draws air directly through the intake vents during flight, channeling cooling breezes over the main processor heatsink before venting out through the rear exhaust ports. This passive-active hybrid thermal layout ensures that even during extended high-bitrate 4K recording sessions in warm weather, internal temperatures remain within optimal operating parameters. Autonomy and intelligent tracking modes form the emotional core of why users love this specific line of flying cameras. A faceless creator, solo adventurer, or outdoor athlete does not want to manipulate complex dual-stick transmitters while trying to perform an activity. They want to press a button, launch the aircraft into the air, and have it follow them flawlessly through unpredictable environments. The subject tracking suite built into the DJI Neo 3 leverages advanced machine learning vision models capable of recognizing complex human motion, bicycle vectors, and vehicle trajectories in real time. The drone does not merely follow a target, it predicts movement patterns based on velocity, acceleration, and environmental obstacles. Imagine sprinting through a dense woods or riding a mountain bike along a winding dirt track. Previous tracking systems would frequently lose sight of the subject if a tree trunk or low-hanging branch momentarily obstructed the camera's view. The tracking engine inside the DJI Neo 3 utilizes predictive spatial memory algorithms. If the subject is briefly occluded by an obstacle, the drone continues along the logical intercept trajectory, reacquiring the lock the split second the target reappears on the other side. This continuity ensures seamless, unbroken tracking shots that look like they were filmed by a professional human camera operator operating a full-scale tracking rig. Obstacle avoidance in ultra light drones has historically been limited by weight restrictions, forcing manufacturers to omit sensors on the sides or top. However, sensor miniaturization has progressed rapidly. The DJI Neo 3 integrates multi-directional optical vision sensors combined with time-of-flight infrared distance measurement modules embedded seamlessly into the outer housing. These sensors map the surrounding environment in three-dimensional space, constructing a real-time point cloud mesh of nearby structures, foliage, power lines, and terrain elevation changes. The flight controller uses this spatial map to dynamically route around obstacles rather than simply coming to an abrupt, jarring stop in midair. This dynamic pathfinding capability opens up incredible creative possibilities for cinematic flying. The DJI Neo 3 can execute complex automated flight movements such as tight spirals, dramatic reveals over cliff edges, sweeping flypasts, and precision low-altitude ground chases with complete safety assurance. If an unexpected gust of wind pushes the drone toward a wall or tree branch, the automated flight safety systems make instantaneous micro-adjustments to the rotor outputs, repelling the aircraft away from hazards without disrupting the smooth movement of the camera shot. Control options for the DJI Neo 3 cater to every skill level and shooting style. For absolute simplicity, gesture control and smartphone-based quick launch modes allow instant operation without pulling out extra gear. You can pull the drone out of a jacket pocket, place it on your palm, tap the top button, and watch it rise into a steady hover, ready to obey basic hand movements or execute automated quick-shot orbits. But for experienced pilots who want total tactical control, the aircraft offers seamless compatibility with multi-frequency dedicated remote controllers, ultra-low latency FPV goggles, and motion-sensing hand controllers. The inclusion of immersive FPV motion control compatibility is particularly exciting for speed enthusiasts and dynamic video editors. Pairing the DJI Neo 3 with first-person view goggles transforms the microdrone into an agile cinematic cruiser. You can swoop through narrow indoor spaces, dive down building facades, and glide millimeters above water surfaces with intuitive wrist movements. Because the integrated propeller guards protect both the aircraft and surrounding objects from incidental bumps, flying in tight indoor environments or near people becomes stress-free, opening up a whole new horizon of real estate tours, event coverage, and high-velocity action filming. Audio recording during autonomous drone tracking has always been a major technical challenge. Propeller noise typically drowns out ambient sounds and vocal dialogue, rendering direct audio captured near the aircraft unusable. To address this, the DJI Neo 3 integrates advanced digital audio syncing protocols that connect directly to wireless lavalier microphones and smartphone audio inputs. The control app runs active noise suppression algorithms that scrub high-frequency motor whine from the incoming audio stream in real time, matching the clean voice track with the high-definition video recording. Solo creators can speak naturally to the camera while walking or running, capturing professional vlogs with crisp, isolated dialogue without needing tedious post-production audio editing. Internal storage capabilities have also received a massive overhaul. MicroSD card slots can sometimes fail, get corrupted, or prove to be a bottleneck when writing ultra-high bitrate 4K video streams. The DJI Neo 3 comes equipped with a substantial chunk of ultra-fast onboard solid-state storage. This high-speed internal memory ensures that even if you forget to insert a memory card before rushing out to film, you can capture hours of high-resolution footage directly to the internal flash memory. Transferring the data off the drone is faster than ever thanks to high-speed wireless connectivity and direct USB-C fast data export protocols, letting you dump gigabytes of raw footage to your phone or laptop in seconds. Wireless transmission tech forms the digital tether between the aircraft in the sky and the screen in your hands. Signal drops, video latency, and frozen live previews can ruin the flying experience and create dangerous situational awareness gaps. The transmission technology built into the DJI Neo 3 utilizes smart adaptive frequency hopping protocols that automatically navigate through crowded wireless spectrum environments. Whether you are flying in a dense suburban neighborhood packed with Wi-Fi routers or across wide-open rural terrain with signal obstacles, the live video feed remains crystal clear, delivering low-latency 1080p preview feeds over remarkable distances. Software integration and automated post-production workflows complete the ecosystem around the DJI Neo 3. The companion mobile application features AI-assisted video editing templates designed specifically for short-form content platforms and long-form video platforms alike. With a single tap, the software scans your raw flight footage, highlights the smoothest tracking moments, applies color presets tailored to the scene's lighting, syncs movement beats to royalty-free background audio, and prepares the clip for instant export. This frictionless pipeline reduces the time between capturing a creative idea in the field and publishing a finished master clip online. When analyzing the broader competitive landscape, the emergence of the DJI Neo 3 sends ripples through the entire consumer tech industry. Rival manufacturers are finding it increasingly difficult to compete with the vertical integration, manufacturing scale, and software refinement that this platform represents. By consolidating high-end imaging, advanced autonomous flight safety, long-range transmission, and rugged compact structural design into a single package, this aircraft establishes a new baseline for what consumers will demand from personal video gear moving forward.